The fish population of a fish farm in t years is modeled by the logistic function P of t equals 1,800 divided by the sum of 1 and 9 e to the power of negative 0.9t. Number 1, what is the initial fish population round to the nearest fish? The initial fish population is the population at time t equals 0, which indicates we determine P of 0 to determine the initial fish population. Subbing in 0 for t, notice we have e to the power of 0, which equals 1. The denominator simplifies to 1 plus 9, which equals 10. And 1,800 divided by 10 equals 180. The initial fish population is 180 fish. Number 2, what will the fish population be in 2 years? Again, round to the nearest fish. To determine the population in 2 years, we determine P of 2 by substituting 2 for t. If we want to, we can simplify the exponent. Negative 0.9 times 2 is negative 1.8. And now we go to the calculator. In cell 2, I've entered P of 2. Notice I left the exponent as a product. To do this, though, we do need the exponent in parentheses. Otherwise, the times 2 would not be in the exponent position. Rounding to the nearest whole number, we have 724 fish. Number 3, how long will it take to reach a fish population of 1,300 fish? Round to the 10th place value. To answer this question, we need to substitute 1,300 for P of t and solve for t, which results in this equation. We'll go ahead and solve this algebraically on the next slide, and then I'll also show how to solve it graphically. Starting with the initial equation, let's clear the fraction from the equation by multiplying both sides of the equation by 1 plus 9 times e to the power of negative 0.9t. Notice on the right we can simplify. This quotient equals 1, and therefore the right side simplifies to 1,800. Next, we'll divide both sides by 1,300. Simplifying, 1,300 divided by itself simplifies to 1, and the right side simplifies to 18/13. Next, subtract 1 on both sides. 18/13 minus 1 is equivalent to 18/13 minus 13/13, which equals 5/13. For the next step, we need to divide both sides by 9, but because the right side is a fraction, we'll multiply both sides by 1/9 instead. Notice on the left, 1/9 times 9 equals 1, giving us e to the power of negative 0.9t equals 1/9 times 5/13, which is 5 divided by 117. The next step is to take the natural log of both sides of the equation. From here, we'll apply the power property of logs on the left. Natural log of e to the power of negative 0.9t is equal to negative 0.9t times natural log e. Natural log e is equal to 1, and therefore to solve for t, we divide both sides by negative 0.9. Simplifying, we now have t equals natural log of 5 divided by 117, all divided by negative 0.9. And now we go back to the calculator. I've entered the expression for t in cell 4. To the nearest tenth, we have 3.5 years. Or to solve this graphically, notice I've entered P of t in cell 1, and now if we enter P of t equals 1,300 and turn this graph on, we can also determine t by determining the t coordinate of the point of intersection, which we can see gives us the same value of t of approximately 3.5. So going back to our question, we now know it will take approximately 3.5 years for the fish population to reach 1,300 fish. And finally, number 4, what is the carrying capacity for the fish? Which means as the time increases, what will the fish population approach? We can answer this question by determining the right-hand behavior, which is determining what's happening to the value of P of t as t approaches infinity. To do this, it'll be helpful to rewrite e to the power of negative 0.9t using a positive exponent. 9 times e to the power of negative 0.9t is equivalent to 9 divided by e to the power of positive 0.9t. Another way to express the right-hand behavior is to write this as a limit, meaning the limit as t approaches infinity of P of t. And notice as t approaches infinity, 9 divided by e to the power of 0.9t approaches 0 because the numerator is the constant 9 and the denominator increases without bound, as t approaches infinity, which indicates as t approaches infinity, the function value approaches 1,800 divided by 1, again because 9 divided by e to the power of 0.9t approaches 0 as t approaches infinity, which indicates as t approaches infinity, p of t approaches 1,800, which is the carrying capacity for the fish population. I hope you found this helpful.